Okay, this is on solving trig equations. We've done all this work with trig, proving identities, working like with law of sines, law of cosines, but we have not actually solved trig equations. And there's a clue here in the title, and it says using special angles. So that usually means 30, 60, 90, 45, 45, 90, and your quadrantals. So that's why you need your chart. Now, what you ought to look at on your chart is, did you ever go back up at the top and put in all the radian values for your angles? Okay. If you did, that will help you on this section. If you didn't, you might want to go back and do that. Okay. On this solving trig equations, I just want to go through a couple of examples and put these down as examples in your notes. If they say, and all they're going to do is say solve, they will usually give you some restrictions. If they don't give you the restrictions, because we're on a coordinate plane, you could go around an infinite number of times. So on this one, they're going to say solve, and their x is going to be less than or equal to 2 pi and greater than or equal to 0. Okay? And they might do it in radians. They might do it from 0 to 360 degrees. Okay, so on this one, say they give you 2 sine of x minus 1 equals 0. Now you're basically solving these just like you would algebra equation. Okay, so you want to get the sine x by itself first. So you got to get the 1 to the other side. So we're just going to add 1. Okay, and then you get 2 sine of x equals 1. You want to get the sine of x by itself, so divide by 2. So now you have sine of x equals 1/2. Now I could have you do these on the calculator, but first we're going to do it using your chart. Okay, so basically you're saying, I know the value of the function is 1/2, I don't know the angle, and they are special angles, so look across on your chart, go across the sine. Where is the sine equal to a positive 1/2? 30 degrees. Where else? 150. Now, in terms of pi, okay, because they're going to put the answer in the back in terms of pi, so the 30 degrees is pi over 6. If you don't have that on your chart, write it above it. Remember, you can multiply 30 by pi over 180. Remember? So 30 degrees is pi over 6. 150 degrees is 5 pi over 6. And those are the two values that would solve that. They call it a conditional equation from 0 to 2 pi. If I don't put those in, then you have an infinite number of answers. So you're basically solving it just like you would a algebra equation. Okay, everybody okay on that one? Okay, another example. Same thing. They're going to ask you to solve. Okay, and on this one they give you 2 cosine squared x plus sine x plus 1 equals 0. This time they're giving you directions and they're putting in terms of degrees. So from 0 to 360 degrees. So it's 2 cosine squared x plus sine x plus 1 equals 0. Okay? And it's a squared term. Can you factor it? There's nothing in common all the way across. Okay? I can factor, try it. No, I can't because it's in, sorry, we got to get it in terms of, what is this? We got to get it all in terms of cosine or all in terms of sine. I can't convert the sine to cosine. But cosine squared, what is that? So on your card you're looking at this. Sine squared theta plus cosine squared theta equals 1. So if I want to convert cosine squared, get this by itself, I need to subtract sine squared, right? You agree with that? Okay, so I got cosine squared theta equals 1 minus sine squared theta. So I can put in 1 minus sine squared, except we're using an x, plus sine of x plus 1 equals 0. Okay, distribute the 2. Okay, so I get 2, okay, minus 2 sine squared x plus sine x plus 1 equals 0. I end up with a negative 2 sine squared x plus sine x plus 3. I can combine these two like terms. Now, you are used to factoring with a positive right here. Okay? So, multiply by negative 1 all the way across. If I multiply by negative 1, that's going to change that to 2 sine squared minus sine x minus 3. It just changes all the signs. Now is it factorable? Okay? There's nothing in common, but it's just like I need 2 sine x times sine x. If I FOIL that, that'd give me 2 sine squared x. This tells me the signs are different. One's positive, one's negative. Okay? And what do I need? Try one here. Try it. Two numbers that multiply together give you 3. So 3 and 1. What do I need to put here? The 3 in here, the 1. Okay. And I need a minus and a plus. I agree with that. That'd give me 2 sine squared plus 2 sine minus 3 sine. That'd give me the negative 1 sine minus 3. Agree with that? So then set both those equal to 0. And if you add 3, and divide by 2, and this one subtract 1. Now, you can look across your chart, and you're not going to find 3 halves. Now, think about your sine graph. Go back to the sine graph. Remember the sine graph? It went like this, right? Did it ever go above 1? No. So, reject this. That's not possible. If you did this on your calculator, try it. Put in, make sure you're in degree mode, and put in 1.5, or do the inverse sine of 1.5. Make sure you're in degrees. Should say there. Yep. Mode. Yep. If you do inverse sine of 1.5, it should give you an error. Sine won't ever go above 1. It won't ever go below negative 1. So reject that. Now look on your chart. Go across on sine for negative 1. 270 degrees. So x is 270 degrees. They wanted this one in degree mode. Okay, and that is the only solution between 0 and 360. Okay? So you may end up using factoring. You also use your identities on your card. Okay? Let's look one more example. And they will just say solve. Okay, sine of 2x, okay, equals radical 3 cosine of x, and x is less than 2 pi and greater than or equal to 0. Both those, they're equal to. Okay, now this is using something I put on your card yesterday, sine of twice an angle. Okay, you can't work it the way it is. You got to get it back to x. Sine of 2 theta. Should be, isn't it 2 sine of theta cosine of theta? Find that on your card. So 2 sine of theta, or sine of x cosine of x equals write a note out here. You got to use a double angle formula on your card when you're working that one. Okay. Now you got to get it in standard form equal to 0. So I would subtract the radical 3 cosine of x. Okay, these are not like terms, so just write them down. 2 sine of x cosine of x minus radical 3 cosine of x equals 0. What's in common in both terms? Cosine of x is in both of them. Factor that out. So if I take out a cosine x out front, what's left out of this first term? Just the 2 sine x. And left out of this one is minus radical 3. Okay. Now you set both factors equal to 0. Either cosine of x equals 0 or 2 sine of x minus radical 3 equals 0. Add radical 3. And you get 2 sine of x equals radical 3. Divide by 2. So you get sine of x equals radical 3 over 2. Okay. Now look at the cosine first. Go across on your cosine. Where is cosine equal to 0? And I'm going to go in radians. Cosine's equal to 0 at pi over 2, so x is pi over 2. Where else? Cosine's equal to 0 at 3 pi over 2, or 270. So 3 pi over 2 is same as 270. If you don't have on your chart, change it. Okay, and then we need sine of x, so go across your sine. Where is sine of x equal to radical 3 over 2? 60, and that's the same as pi over 3. So if you don't have 60, put that up there. Pi over 3. Where else? Is that it? For sine? That's the only one where it's positive. Hang on. 2 pi over 3. Sorry. Okay. So we should have 4 answers. Okay. So on this one we'd have pi over 2, 3 pi over 2. Okay, we've got all 4 of them. Pi over 3 and 2 pi over 3. Okay. So basically you're going to do solve trig equations using your chart, using your algebra, factoring. Okay, you do use your card and your identities. Okay? Okay, so I'll give you time to work on your assignment. Priority is notebooks. Okay, you need to get your notebooks handed in. Okay?